In this chapter, we're going to go through some of the jargon and buzzwords and standards for voice over IP. The most important standard is H.323, which is an umbrella standard that defines a number of different components of a voice over IP system. But to get started, we'll just take an overview of the different components, and then we'll look at the H.323 world next. We start off on the left side of the picture with the terminals, and terminals can include IP phones and soft phones, and if you think about it long enough, you'll realize that a voicemail system is a terminal in a voice over IP system in some cases. Then these terminals are connected together via an Ethernet LAN. And the Ethernet LAN consists of in-building wiring, so these are the category 5, 5E, and 6 twisted pair cables, terminating on connectors and connected together via Ethernet switches. The gatekeeper is a set of functions to control a group of terminals. And then in addition to those basic control functions, then we would usually have call management functions, which in different vendors' parlance and different standards might be called supplementary services, or they might be called call management services like call forwarding and ring again and voicemail and all of those sort of things. The call management functions could be living in the same box as the gatekeeper function, or it could be on a separate server. In any case, we have to try to concentrate on functions rather than product packaging at this point. Another element is the router in the middle of the picture, and the router is the device that connects the in-building cabling to the outside world. It acts on IP packets and looks at the addresses on the packets and decides where to route them. For communications to the public switch telephone network, we need a gateway. And remember, a gateway is a device that converts two things. One, the format of the media, so that the way the voice is coded in this instance, and also the signaling, how calls are set up in the voice over IP world, translated to how calls are set up in the public switch telephone network. If we're going to connect onto IP networks, then we need to have a firewall, particularly if we're going to try to communicate over the internet, which we normally would, because you have to keep in mind that part of the whole story here is to have integrated voice and data. So even though we've got pictures of IP phones on that LAN, there's also going to be your desktop computer on that LAN as well. So your IP phone is going to be connected to the internet, whether you like it or not. And we have to have a firewall in between those two things. And what a firewall is a computer that can bring in a whole message that's trying to be transmitted when we're talking about data communications, and it uses application level software to look at that message and see what it is, maybe scan it with a virus checker, and if it likes it, then it makes up new packets and relays them onto the safe side of the network. When we start talking about voice over IP, obviously it's not going to work to bring in the whole message and scan it before we relay it. So we start looking at techniques where it just looks at the first few packets to try to decide what that stream of information coming through is and whether it's allowed to go in or not. The IP networks that we would be discussing would be the internet, and then another possibility would be a commercial IP network, which uses all the same protocols as the internet, but the access is controlled, and we use encryption to provide security. And since the access is controlled, we can do some traffic engineering, and these are called IP VPN services. They were designed for data communications. And eventually what we're going to have is native voice over IP carriers, where they can carry IP packets, they can distribute them to lots of different places, and they provide some quality of service guarantees so we can get good quality reconstructed speech at the far end. So that was an overview of the basic functions and components in a voice over IP system. Now we're going to get a bit more rigorous and talk about the standards and the official nomenclature. And there are quite a number of different standards and standards bodies that we end up talking about when we're talking about voice over IP. The most important probably is the ITU, the International Telecommunications Union. And anything that starts with a letter and then a dot is a standard from the ITU. And the most important one as far as we're concerned is H.323. And we're going to look at H.323 in detail on the next slide. But what it is an umbrella standard. And what that means is that it points at a number of other standards to say how you should implement various functions, like say voice coding and call setup and things like that. And it defines a number of system components and what the functions of those are and how they should interact. One of the standards that H.323 points to is a standard for coding voice, and these generally are in the G series of standards from the ITU and the G700 series in particular. And there are a number of different codecs specified in the G700 series. Codec stands for coder, decoder, and this is the specification of how we take speech that's been through just a raw analog to digital conversion, how we take the digits that come out of the analog and digital converter and compress them down and represent them as either a stream or possibly as bursts of sound. So when somebody says codec, what they're referring to is a standard for how to code digitized speech into a particular format. And sometimes they mean the actual hardware chip that does it, but it's the algorithm as a standard underlying it. In addition to the ITU, another standards body that we run into is the Internet Engineering Task Force. And you can get an idea of the sort of Berkeley granola history of some of these people, because a standard from the IETF is not called a standard, that's called a request for comments. So we're not telling you how to do this, we're asking for your comments on this idea. Not that we would ever listen to them or anything like that. Two standards from the Internet Engineering Task Force, RFC 1889, the Real-Time Transport Protocol, is critical in a voice over IP system, and RFC 2543, the Session Initiation Protocol, is one that we're going to talk about as an improvement on some of the call setup standards that the ITU proposed. There are more standards bodies. Another one is the IEEE, the Institute of Electrical and Electronic Engineers, headquartered in Piscataway, New Jersey. And this is an industry association, and they define standards for quite a number of things, and they define standards for how to do LANs on copper wires and also wireless. Like we've got the 802.11 standards for wireless LANs. The 802.3 series of standards define what is commonly referred to as Ethernet LANs. So we end up having to deal with that, because as we're going to see, when we're talking about voice over IP inside a building, we're talking about voice that gets coded with one of the codecs, then it goes into IP packets, and those get carried on LANs. Now, what the LANs actually run on inside the building is copper wires. And the standard for how to do copper wires inside a building for our purposes comes from the Telecommunications Industry Association, the TIA, which is a subgroup of the Electronic Industries Association. And they've got a number of standards. One of them is TIA 568. And in that standard, they defined a number of categories of cables. And the ones that we're interested in when we're talking about Ethernet LANs are cables that have 8 wires in them, 4 pairs. And there are specifications as to transmission characteristics for these cables, and each of these sets of specifications is called a category of cabling. And they used to have 5 categories. Category 1 was rusty twisted pair. That's the stuff that goes to your house for telephone service. Category 2 was multi-conductor cables for old key telephone systems. Category 3 was for Ethernet. Category 4